C++ does have a fundamental ability to work with arrays, that is, collections of all the same kind of element, 12 integers or 15 employees or whatever. You can declare an array on the stack in local scope or on the heap on the free store. When you declare an array on the free store, you use new square bracket instead of just new when you just create a single instance up on the free store. And if you're doing manual memory management of your C-style array, you must also use delete square bracket to clean it up. Square bracket is also how you get to the individual elements of the array. So if you have employees as an array and you want to get to the third element, you would use employees square bracket 2 square bracket. Why is it 2? Because our array indexes are 0 based. So 0, 1, 2 is the third element of that array. If you want to make a two-dimensional array, some sort of matrix, people coming from other languages sometimes want to use a comma syntax. It's not how it's done. It's a pair of square brackets like this. X, Y, each surrounded in their own square brackets. You will see square brackets used a lot to access individual elements of arrays, but you'll also see pointer manipulation, taking the name of an array and using it as a pointer and adding numbers to it. And it's pretty smart. If you have that array of employees, called them employees, and you say employees plus 3, that actually does pointer arithmetic and increments the pointer by 3 times the size of what this is an array of and gets you 3 elements further along that array. I'm not saying arrays are awful, but many times they have no idea how big they are. And even when they do know how big they are, they trust you to do the right thing and don't do any bounds checking. And if you set up an array to hold 4 elements and try to add a 5th element, well, I don't know what will happen. It actually depends on the setup of your program. I'll tell you what won't happen. You won't magically get a bigger array. You won't get a runtime error saying, hey, what are you doing? You just added 1 element too many. You probably will get a runtime error later, hundreds of lines away from where you did the bad thing, and can be very difficult to find these. I don't think you should be using C-style arrays except in some very, very specific circumstances. In general, you should use vector from the standard library or some other collection from the standard library. But it is a good idea to be able to read code that works with these arrays, and there may be some very performance-sensitive circumstances when you want to throw all the checking and automatic everything away and use them. But let's focus on reading them, and I'll show you some code that works with these kinds of arrays. Here, I'm declaring an array of integers, which is not very imaginatively called ints, and it can hold 3 integers. I'm going to set some values using the square bracket notation and some values using pointer manipulation. So here, ints plus 2 points 2 integer lengths past the beginning of ints, and then I dereference that pointer and put 2 there. Another way to get values into an array like this is when you first declare it to initialize it. This brace bracket notation is called initializer syntax. You can only do this for fundamental types, ints and floats and the like. If you want to make an array of, say, employees, you can't use initializer syntax, and therefore when you declare it, it will first create however many elements there are in the array using the default constructor, and then you'll have to reach out using set methods to change their values. It's kind of awkward and inconvenient, so some people will instead make an array of employee pointers, which can be null, and then new up those employees or set the employee pointers to point to real employees that have values set into them and that were created with constructors. You can also allocate that array on the free store if you like, using the new with square brackets, and then access its elements. again using either the square bracket notation or doing some pointer arithmetic and dereferencing it. You can go through a loop like this to get to the individual elements of a C-style array. You will also see people in their loop actually incrementing a pointer rather than an index that's going to go into the square brackets. Both of those approaches are just fine. I have a couple lines here that look very similar, and you'll spot lines like this almost anywhere that does work with arrays. It's a bit of a trick, but what I want to show you when I run this code is that the trick does not always work. So in both cases, what I'm saying is use this size of operator to tell me the size of the whole array, and then divide that by the size of the first element of the array. And if this works, it gives you the number of elements in the array, which would be cool. Well, you'll see what happens when we run it. I mentioned everything you knew you have to delete, and everything you knew with square brackets, you must delete with square brackets. So here we newed up 4 ints out on the free store, and here we're deleting 4 ints out on the free store. And then finally, I have a little bit of code just to show you how to work with two-dimensional arrays. This is a 2x3 matrix. I'm showing how to access the individual elements of the matrix using the doubled up square bracket notation. So let's run this and watch what happens. Here's the code in main that calls arrays. We'll step in and we'll watch. So down here, this ints, this is not set to this, uninitialized memory kind of opinion. It's been allocated at this point. We can hover over it and I can expand it, and you'll see that there are 3 elements in ints and they're all nonsense values. Then as we go through, one at a time, they're getting set. So now the first element has been properly set to 0. Another square bracket. And now the second element has been set to 1. Sounds great. Now we're going to do it with pointer syntax. 0, 1, 2. And now this looks bad. Why are we about to do number 3? 0, 1, 2, 3, that's the 4th element of ints. There are only 3. If you were hoping for some kind of runtime error or somebody yelling at you, nothing happens. That 3 gets put somewhere. It doesn't get put into ints, which still only has 0, 1, and 2 in it. It just gets tromps on some other memory. Now, in a debug build, there are some protections about where your memory gets tromped on. In a release build, it's actually possible with the right level of tromping to tromp on the executing code. That's a buffer overrun attack. And generally speaking, a lot of terrible things will happen. One of the things that'll happen is someone will say, I know I have a breakpoint on every line that changes the value of X, and none of my breakpoints are hit, so X's value isn't changing. But it is changing because when I get to this other breakpoint and I look at X, it has a different value. And this is one of the ways that can happen because I reached out through the ints array and wrote some memory that didn't actually belong to the ints array. And don't think this is because I used the pointer notation. The same exact thing can happen with the square bracket notation. So let's carry on, cheerfully unaware that we've done this bad thing. And take a look at our floats array. You can see that it has the values 1, 2, and 3 as expected. That's what we initialized it to. And then we'll take a look at the array that's out on the free store. Now, what you get back from the free store is an integer pointer. And if I hover over this, it really doesn't give me the same information that it did with the locally scoped array. It's not showing me all of the elements. It's supposed to have 4 elements. I can go through setting their values. They're very definitely there, but they're not available to me like this with the drop down. That's showing me a 4 because the first 4. Now I can select like this and hover and see that AI at 0 is 4, and then select like this and hover and see that AI at 1 is 3. It's not that the debugger doesn't know the values, it's that it doesn't know really that AI is an array. So if I put my values 4, 3, 2, 1 in, and then I go through and change them again in this one, let's just run down to here. Here we're going to repeatedly change them, so now AI at 2, well, that's also 2 because I counted down from that way. AI at 1 has the value 1, not 3, because we went through in this loop and set each element at I to the value of I. It's really only an issue in the debugger, but it can also be an issue if you're passed an array into a function. Almost always you'll see that someone also passes in as a separate parameter the size of the array. And that's because the array really doesn't carry that information reliably with it. Here I'm going to try to figure out the size of both my locally allocated array ints, that's the one that debugger can show me the 3 elements in it, and my heap allocated or free store allocated array AI that the debugger can't show me what's in it. And if I just quickly step over these 2 lines, it comes back that local size is 3, yay, and that free store size 1. So it's not able to calculate the size of that. So this code here that created it needs to sort of set aside that number 4 somewhere, because I'm guessing this would be a number you'd work out at runtime. If you knew for sure how big it was, you could have allocated it on the stack in the first place. And typically you'll see people passing that around, not only the array, but also the size of the array. And if you contrast to when we were talking about vectors, vectors know how big they are. You don't need to pass a second piece of information around. And of course, vectors magically make themselves bigger when you try to put more into them, which would have been a nice touch. Don't forget that we have put too much out the end of the ints array. So I'm going to hit run and let this finish out. And a wonderful message comes up. It doesn't look like a wonderful message. You're like, oh no, an error. But this is actually really great news that it has found what I did wrong and given me a really big clue that I did it wrong. It says runtime check failure, stack around the variable ints was corrupted. And we all know that, in fact, I deliberately corrupted the variable, but it's telling me exactly who the problem is instead of just giving me a numerical address. So I can now stop the program, take a look at my code, and realize, wow, you know, there's only 3 elements in ints. I can't write 4 into it. I'll comment this out and run again. Just let it run out. So we'll just run out of this arrays function. And we get out without getting that stack corruption warning anymore. By running a debug, getting that runtime check run for us, we're made aware of this bad behavior and we can fix it. This is so much better than it used to be when you get these mysterious changes in your variables and not know where they come from. But if you're expecting any kind of support like making it bigger or giving you an error the minute you do it, you will not get that support. That's why it's a good idea to use collections like